So let us talk on today about the methods of analysis for earthquake resistant design of structure as per IS 1893 part 1 2002 and the modified version is 2016. So whenever earthquakes comes that's gives rise to a different modes of vibration. So here this picture shows the first and second mode of building seismic response. Left side is the first mode of vibration and the right side figure shows the second modes of vibration. What is seismic analysis? Seismic analysis is a subset of structural analysis and is the calculation of the response of building or non-building structure to earthquakes. It is part of the process of structural design, earthquake engineering or structural assessment and retrofit in regions where earthquakes are prevalent. As seen, a building has the potential to wave back and forth during an earthquake or even a severe wind storm, you can say. This is called the fundamental mode and is the lowest frequency of building response. Most buildings, however, have higher modes of response which are uniquely activated during earthquakes. The concept of response spectra was developed in the 1930s, but it wasn't until 1952 that a joint committee of the San Francisco section of the American Society of Civil Engineering and the Structural Engineers Association of Northern California proposed using the building period, that is the inverse of the frequency, to determine lateral forces. The figure just shows the second mode, but there are higher shimmy, that is nothing but abnormal vibrations modes. Nevertheless, the first and second modes tend to cause the most damage in most cases. Now, as per the Indian standard for earthquake design, there are several IS codes are there. Out of that, the very important IS code is IS 1893 Part 4 2002 criteria for the earthquake resistant design of structure, and the modified version is 2016. IS 4326 1976 Code of Practice for earthquake resistant design and construction of building. IS 13920 1993 Code of Practice for ductile detailing of reinforced concrete structures subjected to seismic forces. SP 22 Explanatory Handbook on Codes for Earthquake Engineering. Now, on which factor the response of the structure during earthquake depends? So, response of the structure during earthquake depends on number one, the natural frequency of the structure, which is dependent on the mass of the structure and the stiffness of the structure. Second is the frequency content of earthquake. Third is the amplitude of earthquake. Fourth is the duration of earthquake. And fifth is the ductility. Sixth is damping characteristic, that is energy dissipation capacity. Seventh is the structural integrity. Structural response depends on input motion and structural properties. There are uncertainties in the input motion, that is, what are the various uncertainties in an input motion? Number one, when and where the next earthquake. So we cannot say or predict when and where the earthquake or the next earthquake will come. And if this is so, on what fault or the location, that again there uncertainty, and on what magnitude, that again the uncertainty. Effect of travel path on shaking at a distance. This is what again the uncertainty part. Effect of local geologic topography and soil profile, that are again the uncertainty. So earthquake resistant design concept, if you see the concept of or the design philosophy or the objectives of earthquake resistant design of structure, so that are attributed to different modes of vibration, or that depends on the magnitude and the intensity of the earthquake, and based on that one has to go for the level of the earthquake. shaking. So levels of the earthquake shaking, number one level is the maximum credible earthquake or the maximum considered earthquake, that is what MCE. The most severe earthquake effects considered by this standard are 500 years return period and 2% possibility of occurrence in 50 years. So far as the occurrence of the maximum credible earthquake, that is the earthquake having a magnitude somewhere exceeding 8 and more. So these types of earthquake of magnitude 8 and more, there are possibility, only less possibility, that is 2% possibility of occurrence of that earthquake within 50 years of time. So this is what the MCE. Second level of earthquake resistant design is design basis earthquake, that is DBE, and it is the earthquake which can reasonably be expected to occur at least once during the design life of the structure. If your life of the structure is supposed to be 50 years, so definitely within that particular 50 years of time, so there are possibility, 10% possibility that this DBE based earthquake will happen. What are the objectives of earthquake resistant design? Should the structure be designed to withstand strong shaking without sustaining any damage? Such a construction will be too expensive if you go for assuming the magnitudes somewhere around 8. This gives rise to a expensive design. Second objective, it may be more logical to accept some damage in case of strong shaking. However, loss of life must be protected even in case of strong shaking. So objectives of earthquake design that can be looked in another way also. Building resist the effects of ground shaking. Although they may get damaged severely, they should not collapse during a strong earthquake. So we will go in realistic way such that building resist the effect of ground shaking. Although they may get damaged severely, they should not collapse during a strong earthquake. This is what the first possibility. If you go in unrealistic way, earthquake proof buildings, so building suffers no damage at all even during strong but rare earthquakes. Thank you, ladies and gentlemen. Thank you. Sir, कितने मिनट का होगा?